Hello everyone, welcome to the 6G Architecting Tomorrow series brought to you by Nokia. Today we'll focus on the AI blueprint. I'm Maeder, Head of 6G Technology Marketing at Nokia. It's my real privilege to be a host as we explore this exciting topic. AI is already transforming our daily lives and reshaping industries. Its impact is only accelerating. In telecom, as we look ahead, one thing is clear. AI won't just support 6G, it will define it. But making 6G truly AI native goes beyond powerful algorithms. It requires the right data, harmonized standards, and deep collaboration across the entire ecosystem. To help us unpack all of this, I'm thrilled to be joined by four brilliant minds who are at the forefront of this transformation. Andreas Maeder, our head of AI ML at Nokia Standards. Andreas brings over 20 years of experience in the telco industry and is passionate about driving this shift toward data-powered mobile networks. Great to have you, Andreas. Afsaneh Gharouni, Senior Research Specialist at Nokia. Afsaneh is actively contributing to both 5G and 6G standardization, especially around data and AI-native architectures. Welcome, Afsaneh. Abdelkader, Senior Research and Standardization Engineer at Nokia. Abdul is specialized in machine learning-based wireless network optimization. He brings a unique combination of deep technical expertise and hands-on experience. Thanks for joining, Abdul. Last but not least, we have Dani Korpi, Senior Radio Research Specialist at Nokia Bell. Dani plays an instrumental role in building the AI-native foundation for future networks. He led the development of the very first AI-native interface proof of concept, an award-winning breakthrough. Welcome, Dani. Well, with this very strong line of speakers, I can't wait to dive into the insights. So, Andreas, can you start by giving us a sense of how AI is already making an impact today? And why is it so critical that we build an AI-native 6G from the very beginning?
Thanks, Amanda, for the kind introduction, also for the excellent question. AI will break the limits of traditionally engineered networks. Why do we think this is the case? For decades, we have tweaked thousands of network parameters by hand, squeezing out incremental gains in spectral efficiency and cost performance. We know this because it's a hard work. But the complexity of the network is exploding, and classic approaches are hitting hard ceilings. Therefore, we turn to AI already. Now, AI-enabled networks for operations bring machine learning insights into management, and we see gains from in the operational field. But the next leap are AI-native networks, pervasive intelligence in control, management, and user planes to unlock new S-curves of performance and TCO. While the technology is early, its rapid evolution promises breakthroughs in reliability, efficiency, and scale. And that's basically what we'll see with 6G native networks in the coming years. But it's not only that. As AI evolves, it is driven by the rapid evolvement of technology in all areas, especially driven by the capabilities of large language models, of generative AI, as we see the explosion of compute availability, as we see the impact of synthetic data, which allows us to create even more powerful models. We see that AI will rapidly reshape the whole telco industry. So it's not only about the network itself, it's also about the way of working. We will see AI augmented workflows, meaning that we move from a purely tool-based way of working, where we think, what kind of tools do I need to fulfill my task, to task-based way of working, where we basically say, I have a task to fulfill, and I ask my AI system, I ask my AI assistants, how can I fulfill this task? And it does it partially for me already. And the final step are AI agents, where we task AI agents to do something, and they autonomously do it and report back the results. And then we start a circle of refinement, finally until the results are good enough. It also has an impact on the design of networks. Traditionally, networks are created by engineers who are deeply involved into the technical details. They create algorithms, complex algorithms, which help us to further enhance the performance of the network. With data-driven R&D, we need a bit different approach. We also look on the data. We learn from the data how we can improve the networks. And we basically give the data to the machine learning models in order to improve the performance without even knowing exactly how does it work in detail. So data together with ML ops kind of operations allows us to rapidly increase the innovation cycle and the performance of the networks. Finally, we have an impact on operations. We will see a way of continuous optimizations of operation and performance. How? By introducing radio ML ops. It means that we continuously are monitoring the performance of our models. We collect the data which is needed to trigger a retraining. We have an automated way for development and testing. And finally, we bring the models back into the operations, into the field. In that way, we have an ever improving cycle of continuous optimizations of our network. This is the promise, and this is the impact of AI in the telco industry. But it's not only about that, it's also about value, of course. What value do we want to create? What value do we create in AI native 6G? We would like to create growth. We would like to drive cost efficiency. We would achieve a performance leap. We would like to grow revenue. How are we doing this? Data as a service will become more important because we need high quality and curated data products for AI and ML solutions. And it's not only about data, it's also about the knowledge which can only be provided by specialized domains in the network to enhance the context in which AI solutions operate in. We see AI as a service as a field with large potential about hosting, inferencing, training, fine-tuning services for any kind of AI workloads. We see agentic AI systems where AI agents for end customers and for network operations are operating in the field, collaborating together towards a common goal. We see customer experience enhancement with superior optimization of service quality based on data and AI, with AI-based solutions in the radio access network, in the core and end-to-end. We see security and trust where AI helps us to detect threat and mitigate threats in a holistic manner. And finally, we have to look closely and consider it in everything what we are doing, sustainable and energy efficiency, especially also for AI-based solutions. How to get there? What are the key drivers to unlock the full potential of AI? There are basically three key drivers which we need to realize. First one is data. Data is the foundation and the fuel of AI. Without data, there is no AI. Therefore, it's important to have universal access of data in a way which is transparent and fair, which allows all key players in the ecosystem to access the data which is needed to create great AI solutions. In order to do this, we need standardization. Without standardization, we cannot unlock the full potential of AI native 6G. The goal is to create an open and thriving ecosystem to foster new innovation based on AI. And for this, we need standardized key enablers. And finally, it's co-creation. Co-creation is the path to discover real-world value and to understand the impact of the real world to our concepts. Back to you, Amanda.
Thank you, Andreas. That was a great overview of where we're headed and why. You touched on the aspect of data, so let's turn to Afsaneh to take us deeper into this topic. Afsaneh, what exactly do we mean by data and why is it so important?
Thank you, Amanda. So as Andreas also mentioned, this data is the foundation and fuel for AI. Basically, with simpler, or let's say less computational resources, we can have simpler models, but without data, there's no AI. So when we talk about data in the context of the network, we mean both real and synthetic data. Real like network data, for example, key performance indicators, but also user and physical world information, and synthetic like digital twin data. And of course, there has been a lot of new emerging use cases, for example, in network use cases like core network analytics or analytics for, let's say, network management, agentic AI, immersive experience, and so on. And of course, for all of these, we need data to fuel AI. And what we get in return is, again, more data. So we expect to have some impact on the network traffic. And just to give you a feeling about this, you can have a look at this analysis that we are showing here. We will skip the details, but maybe one thing to take from this prediction or from this analysis is that it expects a threefold increase in data traffic in the next 10 years. And from these, 1/3 belongs to AI ML related data. And of course, this is something that today we need to take it into account when we are designing 6G networks. This is, of course, not the only data aspect that we should be mindful of it, but there are many of them, some of them standard relevant, some of them not. But I want to now focus a little bit more on the aspects which are standard relevant, let's say. So the example that I picked for talking about it is data collection. Why do we need standardization for data collection? Because in telco ecosystem, we have different players. We have CSP, device and chip vendor, infra vendors, and each of these have access to a specific part of the data. And also they have their own requirements and concerns. And to be able to do data collection, we need them all to cooperate with each other, which means that we need standardization. For example, to be able to train a model that will be deployed at the G-Node B, we need also some data to be collected from the device side. But to further clarify this, I want to give you a more in-depth example from 5G. This example is actually from the radio domain, but it can still show you how cross-domain and how complex this problem of, for example, data collection can be when it comes to standardization. So at the beginning for the network side, when the model is at the G-Node B, we had two options on the table. Both got agreed. A lot of work is already ongoing in 5G Advanced. But for the UE side, data collection, let's say when the model is deployed at the UE side, the UE needs some configuration and some reference signals from the G-Node B. And then it cannot train its own model in many cases. So this data should be taken to a training server over the top, which means that it will be very challenging to achieve CSP control and visibility. Therefore, if you look at the three options that were really standard relevant for this UE side data collection, there has been no consensus yet in 3GPP. And as I said, the reason is simply that there are so many factors that we need to take into account when we want to select one of these options or when we want to make a decision. I gave you a glimpse of those factors, but there are a lot of other things like whether we use control plane or user plane, how we deal with non-standardized data, and so on. So while there has been a lot of achievements and we have learned a lot, there hasn't been any consensus yet. Okay, so now let's look at what 6G can unlock for us. Here you see three examples. The first one is tailored synthetic data, which is something that we want to be able to fine-tune the models and train better models for example, for AI receivers. The second example is that we want to have support for data collection for continual learning. So let's say so far in some of the domains, we were more focused on offline training data collection, which means that we were assuming that the data will be taken from the network. You will train your model and then you bring back the model for deployment to the network. But of course, we have a very dynamic environment in mobile communications. So it would be very beneficial to also allow the AI model to adjust itself to this dynamic environment, meaning that it can make a decision and then it can quickly see what happens in the network or how the network changes and so on, and accordingly it will adjust its parameters and so on. So that would be the second aspect. And the third aspect that we'd like to also have in 6G is that we know that there will be new data, for example, for agentic AI. Here you see that we can have a human operator. They decide that energy saving should be done for a specific part of the network, and this is something that can be communicated to an agent that can do planning. The agent gets this goal, and accordingly it can define some tasks, for example UPF selection, cell switch on off, and so on. And then there are already some agents also in the network that can perform these tasks, so the tasks will be distributed to these agents, and then we will get to the goal that the human operator wanted it in the first place. And then the point here is that, of course, we will be dealing with control data, which is much closer to natural language. So this is then something new that we can expect also from 6G. So with that said, I hand over to Amanda again.
Thank you, Afsaneh, for that clear explanation of what we mean by data and why standardized data collection is so important. Building on that, Abdul, can you tell us more about how standardization can enable AI native 6G?
Yeah, of course. So when we talk about standards, we need to realize that standards are the key to unlocking interoperability in any technology, not only AI. They usually are the bridge that takes us from one technology generation to the next. Now, if you look at 5G and the focus that we had on AI in 5G, you'll see that 5G was actually all about making AI work as part of the network. This is done through addressing UE device capabilities, so that in order to support emerging and future use cases, but also making data collection and management possible, not only for AI, but for also other purposes. But as you have heard from Afsaneh already, data is the foundation for network intelligence. So a very good data collection and management framework is essential from the very beginning to make sure AI is successful. Now, at the same time that many organizations have worked on AI, this created a little bit of misalignment and fragmentation across organizations, which means that we needed to make sure it's aligned across these different standards organization and ensure consistency and avoid this fragmented specifications. However, when we look at 6G, we'll see that 6G represents a significant leap forward from only making AI work to making AI both trusted and secure. And this is moving beyond simply enabling the AI functionality by prioritizing security and trustworthiness of the AI system and its behavior. And this can only be done if we ensure network control over device behavior as well as data collected. And the trust and the security aspects must be integral design principles in the network design. And this has to be together with a comprehensive testing and certification framework. In essence, moving from 5G to 6G, we're moving from simply enabling AI to ensuring it's responsible and trustworthy, which is crucial for ensuring that the network can harvest the benefits of AI while mitigating any potential risks. Now, if we look at this analogy that we have here is a very powerful way to represent the power of standards. Now, if you look at the power socket types across Europe, you'll see that there are different shapes and types, which creates a little bit of interoperability issues when you're moving across regions. Now, this represents the problems when there is a lack of standardization, which makes it, in some situations, impractical and potentially risky to have this integration in the system. So standardization is crucial to avoid this incompatibility and ensure that functionality are consistent across geographical regions. When we talk about standards and we try to identify what exactly should standards do and do not specify in order to make a system interoperable, but at the same time foster innovation in a fast-paced cycle. In general, we should focus on testability and consistent device behavior while avoiding inconsistent specification or fragmentation in the standards. Ensuring that data sharing, control, and performance monitoring is actually interoperable across different vendors, across different providers. and ensure that sustainability, trustworthy, and security are supported for AI in the network. Of course, developing an end-to-end reference architecture is very important to help us unlock new value opportunities. But at the same time, this has to be done while preserving the flexibility of implementation and ensuring fast innovation cycles. Now, how can we ensure that fast innovation is supported? By avoiding specifying implementation specific aspects like model formats or AI protocols and libraries, which limit the ability of the technology or implementation to go quickly with the progress of the actual technology. Now, let's look at more of our holistic view of how an AI native network should look like. Now, standards should focus on developing an underlying common foundation of enablement capabilities, both for the AI component as well as the data component. Now, from AI point of view, these AI native enablement capabilities range from data and model catalogs to inference and training engines, all the way to compute and storage orchestration. But if we look at the data capabilities, these are more data producer consumer capabilities, referred here as presumer. And this could be in the level of data abstraction, metadata annotation, or even synthetic data generation. Now, if we manage to define in standards these common capabilities, then what we need to do is expose these capabilities through harmonized APIs towards the network, which then enables us to service the pervasive AI that is present across the different domains of the network. On top of that, you need to have an end-to-end view of the life cycle of these AI components in order to orchestrate and coordinate the interaction between these different AI components in the different domains. So, in a sense, if we can achieve that in standards, then we can ensure that that 6G is truly an AI native network, and that AI can thrive and deliver the best possible results in the 6G era. Now, back to you, Amanda. Thanks.
Thank you, Abdul. It's clear that without a shared framework and standardization, innovation simply can't scale. To bring it all together, let's now hear from Dani, who will cover co-creation and how Nokia is turning vision to reality by working hand in hand with partners and customers. Dani, over to you.
Yeah, thanks, Amanda. Yeah, it's my pleasure to present today some of our key research results we have done together with our partners. As Amanda said, so we are not just about talking about AI, but we are also implementing it and showing the real world value we can get with our different AI-based solutions. Of course, as mentioned, so we have done this together with our key partners and our key customers. We have quite a few different projects going on. Today, I will deep dive into two different projects. So we have another one project which is related to AI native air interface, and this we have done together with NTT Docomo, NTT, and SK Telecom. And then we have another very interesting project related to the compression of channel information with the help of machine learning, which we have done together with Qualcomm. If we start with the AI native air interface project, so this we started quite a few years ago already. We basically started the work because we were facing some challenges with the 6G networks, especially in like how do we bring enough additional throughput and enough additional coverage for 6G systems. And we wanted to address these problems with the help of AI. And how we ended up doing that was that we actually implemented a type of an AI native air interface, which gives us more spectral efficiency in the network. And spectral efficiency is a kind of a concept showing, demonstrating that how efficiently the network can transfer data. And this efficiency can be then used for either for improving coverage or improving throughput, or maybe also a little bit of both at the same time. And this is, of course, very important because it gives us then options for optimizing the network depending on the performance requirements. And of course, we wanted to test that how does this actually work in the real world. This we did together with NTT, Docomo, and SKT. we built a proof of concept, which we have been then using to measure the performance of the AI native air interface in quite a few different places. We've done quite a bit of measurements in our own laboratory in Stuttgart, in Germany. And we have also been doing, together with NTT, quite a bit of measurements in Japan. And we are now also looking to extend the measurement campaign to different additional locations, including also some outdoor scenarios, just to see that how robust this kind of a system is and what kind of value we see in the different environments. And here I wanted to show you just a quick snapshot of some of our measurements. So these measurements have been done in our own lab in Stuttgart. It's an indoor scenario. And here we did see throughput gains of in the order of 15 to 20%, depending a little bit on the particular moment in time, as you can see on the graph. But of course, the exact throughput gain will then vary in different environments. But I think the main conclusion from this experiment is that we do see these gains materialize also in the real world with real hardware, which is of course what we wanted to also understand with this proof of concept. The other project I wanted to talk about today is related to the interoperation and compatibility of the different AI models we expect to have in the 6G networks. So we know that the different vendors and different parties have different AI models which need to be able to work together. And also another practical constraint is that typically the different parties are not able to share the exact model architectures with each other, which means that the AI models need to be able to interoperate and to be able to understand each other without having been trained together. And to address this challenge, we came up with a new kind of sequential learning approach where we can basically train two-sided models in a distributed manner to be able to interoperate and so that they are also compatible with each other. Together with Qualcomm, we also demonstrated how this would work in practice. So we built basically a test system where we had a test UE and a test G0P, where the UE was employed with a machine learning model that was basically compressing channel information. And then we had a G0P, a base station, where we had a compatible sequentially trained AI decoder, which was then decompressing this channel information. And we used this channel information for downlink beamforming, where we basically then can measure the quality of the compression and decompression with the downlink throughput. And here you can see some measurements of the throughput gain we did in a few different locations. You can see that we do get quite a nice throughput gain in all the different locations, the average gain being like even above 50%. So this really shows the value of AI, and it also shows that we can achieve these gains taking all of these practical constraints into account. And we can have the models from two vendors kind of to be compatible and also to kind of operate in the real world and show us the value of AI. Yeah, so this was pretty much all I wanted to share with you today. So I will now hand over back to Amanda for any closing remarks. So thanks a lot.
Thank you, Dani, and a big thank to all our speakers for sharing such valuable insights. I've certainly learned a lot. It's clear that building an AI native 6G is far more than just a technological leap. It's a collaborative journey, one that requires data, standards, experiment, and above all, a shared sense of purpose. We hope you enjoyed the session. If you'd like to learn more about Nokia's 6G vision and the AI topic, be sure to visit our 6G page and supporting materials. Thanks for joining us today. We will see you next time in our 6G Architecting Tomorrow series. Bye for now.